Greetings, eager students. Welcome to Earth Science Lesson 1.1. Poof, a universe is born. So, what you're going to need to do today is get out your knowledge pack. It's the one with the pencil in the upper right hand corner. You're going to need to open it up to the very first page and take your notes there. So, let's begin. All right. So, what we're going to do is we're going to give you the scientific story of how the universe began. Okay, where it came from and what it created. And the most fantastical thing about this story is that ultimately we don't know, but seemingly the universe came from nothing. Perhaps what was there, if anything, was this infinitesimally small point known as a singularity. Either way, what we know is about 13.8 billion years ago, that nothing became something. So, this process today is collectively known as the Big Bang. It's not exactly a great name for it because the reality is, fix that there. Sorry, the reality is that the Big Bang didn't really make a banging noise. It wasn't an explosion. It was more like a super rapid inflation or expansion of the universe from this really teeny tiny point. Okay. So, what we're going to go over today is the sequence of events that occurred right after the Big Bang. Okay. Now, when this happened, based on calculations of the expansion of our universe as it is, we estimate that it was between 13.7 and 13.8 billion years ago. Now, to put that in perspective, our sun has been around for about 5 billion years, and the Earth for just over 4.5 billion years. Now, where this occurred was in what is known as a singularity, an infinitely small point containing the entire universe, everything crushed into essentially nothingness. Okay. Now, incidentally, if you're familiar with that word singularity, we also use it in reference to what is created at a black hole. Everything gets sucked into a little tiny point called a singularity. Now, also, if you want to think about it this way, is where did the Big Bang occur? Well, it occurred everywhere. Okay, everything in this particle expanded out. And so everything is technically the center of the universe. Right here where I am sitting, that was where the Big Bang occurred. Okay, where you were sitting watching this, that's also where the Big Bang occurred. That's the center. Kind of strange, I know. Now, when the Big Bang occurred, four things were created. Okay, space as we know it was created. Prior to the Big Bang, if you can call it prior, there was no such thing as space. Also, at this point, is technically the beginning of time. So space occurs in 3 dimensions, and time is the 4th dimension. Okay? Now, in space, we can move forward and backwards and up and down and left and right, but in time, we only have one direction of travel. Okay, the other thing the Big Bang created was matter. All of the stuff of the universe, the stuff that makes me and you and the table and the computer I'm recording this on, that's all made of stuff and matter. And all of the matter in the universe was created at this time. What that means is all the matter in the universe is 13.8 billion years old. So we are all the same age as far as our physical material is concerned. And the other thing that was created, the last of the 4 things here, is energy. That really nebulous idea that things can happen, things can be animated, changes can occur because of this stuff called energy. Now, what was the universe like right after the Big Bang? And when I say right after the Big Bang, we're talking like less than a second after the Big Bang. So here's what it would be like if we could go back in time and check it out. So first off, the universe would have been super hot, way hotter than anything is now. We're talking 1 billion degrees Kelvin. Okay. So that is really, really hot. Like you basically can't get any hotter. Now, everything in the universe at this point was crushed into something about the size of an orange. So as you can imagine, it was super dense. Okay. Everything was smushed in there, just absolutely bursting. The universe would have been ridiculously fast, okay? So you've probably heard that the universal speed limit is the speed of light. That's the fastest that electromagnetic radiation can travel, light, of course. It's the fastest, theoretically, that a bit of matter could travel. However, space-time isn't bound by those same rules. So as the universe was expanding, as space was forming, this actually happened at faster. Whoops, I don't know what happened there. Let's get back to that. This actually happened at faster than the speed of light. Okay. The other thing we would notice about this early universe is that it was impossibly dark. There was no such thing as light because light could not physically escape from the medium. It would have been immediately absorbed by something else. So there was no visible light. The universe was dark, super hot, very dense, and dark. Okay. And lastly, matter as we think of it here on Earth, as in solid, liquid, and gas, wouldn't have existed in that form at that point. It was impossible for atoms to hold together. So the universe existed as a plasma, just a bunch of charged particles. Okay. Think of it as a cloud, but the densest cloud that could possibly exist, of course. All right. So, what happened after that second or so? Well, if we go a bit into the future, as the universe began to expand, it began to cool down. As gases expand, they cool down all the time. You've probably noticed this if you've ever had like a little Coleman propane canister that you use on like a camping stove, that if you run them for a while, as that gas leaves and gets used up, the gas inside expands and the entire canister might frost over as it cools down. Now, once it cooled down enough and the density dropped low enough, all of the light that was bound up in that super dark energy just burst forth in all directions. This is known as the cosmic microwave background, or CMB. Now, what's cool is because literally everywhere in the universe this light escaped, we can still see it in the universe today coming to us. Okay. Also, at this time, as it cooled, the plasma could begin to turn into gas as atoms were able to form. Most of the atoms that were created during this time were the simplest atoms on the periodic table, hydrogen and helium. And there probably would have been a little bit of other small elements like lithium and beryllium, but for the most part, hydrogen and helium were the only atoms in the universe. In order to get the more complex atoms like carbon and oxygen and iron and calcium and things that are in our bodies, we're going to need stars to form first and then die and then explode. So at this point in the universe's history, things were pretty quiet now, and they were pretty uniform, just hydrogen and helium. All right. This is just a quick image of that cosmic microwave background. And one thing you can see about the light is that it's not exactly uniform. There's slightly brighter or denser packets of light in the universe, and some that are a little bit cooler and a little less dense. And those little fluctuations and variations are why we can actually exist today. All right, join us for the next video, 1.2, Energy Powering Nature.